If you're looking for ways to design better products and gain a competitive advantage in your company, we'll show you how. Hello, my name is Don Cooper, presenting on behalf of SIS. Along with me today is Kyle Aruda, my application engineer. Over the next 30 minutes, I will introduce you to some top industry challenges and how we offer an exciting way to achieve both your business and design goals. Most importantly, we'll discuss how companies are gaining a competitive advantage by addressing these design challenges. I will introduce you to 3 key ways Solid Edge with synchronous technology is uniquely qualified to improve your business. We'll also show you inside of this presentation key demonstrations live by Kyle with Solid Edge. Before we get started, I'd like to thank Edison 2 for the use of this image. Edison 2 is a customer of SIS. Edison 2 competed in the Progressive X Prize competition recently in Detroit. The goal was to design a car that could seat 4 people, handle, accelerate, and stop like any 4-passenger car. They had some extremely aggressive fuel efficiency goals as well that they needed to achieve. I'm pleased to announce that Edison 2, with the use of Solid Edge and synchronous technology, was able to design this vehicle and they won the award. It's anybody's guess on when this type of vehicle will hit the streets. But it's just one example of how Solid Edge with synchronous technology is helping companies like Edison 2 design better and gain a competitive advantage. As we get started, I'll introduce you to SIS, Spatial Integrated Systems. Spatial Integrated Systems has been serving the U.S. machinery market for over 16 years, helping companies like NavC and Laserform Machine design better products. The way they've built their business is by delivering superior value with world-class support and partnering with an industrial leader, Siemens. The company provides superior value by providing software, training, support, and implementation services for Solid Edge. With some companies, they provide process consulting to help them leverage their product development processes as a competitive advantage in their business. NavC and Laserform Machine are just 2 clients that SIS has worked with to help them design better and achieve greater business success. It's the goal of SIS to someday earn the respect and honor of having your company logo on their slide as a company receiving value from SIS and Siemens. As a company, department, or individual, we all have goals and targets to achieve. While these goals may differ from group to group, person to person, almost everybody is striving to be more efficient, go faster, or improve something in their design process to gain a competitive advantage. Let's stop for a minute and think about what these goals might be for you. What are your goals? But more pressing, what are your barriers to achieve them? Some of you might instantly know of a few areas that are challenging your design process, and that's great. Some of you might need more time to think about it, and that's okay too. As you give this some thought, let me take you through some of the top industry challenges that might spur your thinking. A recent study by a noted industry analyst, Aberdeen Group, found that companies like yours, some very, very interesting statistics. They found that there's a connection between the top technical limitations and business challenges. What they found was that 39% of designers struggle with model creation when using a traditional 3D design tool. If you've ever used a traditional 3D design tool or considering moving to a history-based system, you're probably aware of some of the top technical challenges that might stand in your way. These systems require models to be built in a certain way, and they use complex rules to preserve the size and the shape of the geometry. Aberdeen Group also found that 57% of designers and engineers lack the ability to alter the existing design. Because traditional CAD requires models to be built and edited in a certain way, making these fast, flexible changes are very difficult and problematic. In fact, over half the respondents claim that traditional history-based systems require that they go back to the original designer to make the changes because of the complexity of the model. If you or your company are struggling to keep up with your increasing customer demands, you're not alone. Responding to customers' needs faster requires the right tool to let you reuse existing data regardless of who authored it or in what system. Lastly, is your company looking for ways to reduce overall product and product development costs? Are you looking for better reuse of existing data from previous designs? How about reuse data supplied from external suppliers or customers? If you said yes to any of these questions, you're not alone. 44% of history-based 3D users worry about having the ability to deal with 3D geometry. Most 3D geometry that comes from imported data must be edited, and integrating those into your existing design becomes problematic. Oftentimes, remodeling is the only option, which means wasted time and money in non-value added activities. Do you want to improve your design process? Not sure where to start? Well, the industry research suggests that investment in better design tools and methods is a value-rich area. Let's take a specific look at 3 areas within Solid Edge that can help improve your business. Solid Edge with synchronous technology helps companies to secure a competitive advantage. We do this in 3 very unique areas. The first area is to accelerate design cycles for faster time to market so that you can respond to your customers with blazing fast speed. Next, we help companies make faster revisions for higher repeat business and lower costs or increase margins. Third, Solid Edge with synchronous technology supports better reuse with existing or imported data, regardless of the author or authoring source, to lower your development cost so that your company can achieve a competitive advantage you're looking for. So let's take a look at the very first competitive advantage. Looking at the competitive advantage of accelerated design. Yes, I know almost every 3D CAD company can make this claim, but what makes us unique? What makes us unique is a disruptive technology called synchronous technology. Synchronous technology is a patented technology available only to Siemens PLM software. This innovation has dramatically changed the game in product development because no pre-planning is required. Since no pre-planning is required with Solid Edge, the user can design in a history-free environment and accelerate the design process. The user does this by focusing on the design intent versus the design tool and not wasting time trying to predict future changes like traditional history-based systems. Full digital prototyping can be achieved inside of Solid Edge. We do this by leveraging a hybrid 2D, 3D design environment. Unlike other 3D CAD systems, Solid Edge offers a common user experience for both the 2D and 3D users. We can offer this because Solid Edge was developed from inception to be an integrated 2D, 3D design tool. We understand the need to import and export 2D data and respect that most manufacturing companies has a need for one common system. We look forward to showing you this capability in the upcoming demonstration. Additionally, Solid Edge gives the user the freedom to redesign on the fly and respond to your customers' demands with lightning fast speed and agility. We do this, and we can do this because of a unique capability in Solid Edge, where the system interrogates the 3D model and automatically captures the design intent. This gives the designer a more productive experience. So, accelerate design. What could it mean for you? The unique capabilities I just reviewed can help your company secure a competitive advantage and get products to market faster, up to 25% faster. Respond to your customers' demands quickly. Ultimately is about designing better. What I'll do now is I'll pass this over to Kyle Ruda to show you what we mean by accelerated design.
Thanks, Don. What we're going to look at here today is I've been tasked to go out and work on our high-performance motorcycle. Now, my boss has come to me and he says, "Hey Kyle, you know Bob, he's been working on this brake assembly, but you know, he's got on vacation and I need you to go out and finish it." Well, as everything else, he comes to me at 4:45 in the afternoon and tells me this. And I really want to get home and be with my family. So I'm going to go out here and finish off the part that Bob has started. And what we're able to do is Solid Edge can go through and just grab the information that I want from other parts in my assembly and go and start my design. Now, I didn't have to go out and create a sketch or anything like that. I'm able to grab this information. The system is able to take that information and get the design that I want. Now, the other thing is that I can go out and I can tell Solid Edge how I want something to be made. In this particular case, I just want to go and grab the information. If the information that I want is not presented to me, Solid Edge gives me the ability through a tool called Quick Pick to go and grab that information that I want and be able to start my design. Now, we have different ways of doing this. The system interrogates the inputs that I'm giving into it and giving me the exact design that I want. Now, also inside of here, we have different ways of doing this. creating my design. You'll see different ways that I'm selecting information from other parts in the system to make sure I have true fit and function and be able to create that very quickly. As we go through this, Don mentioned to you about a history-free system. What we are able to do inside of Solid Edge is, as you can see here, I've made a cutout. I've made a couple of cutouts, and you can see them in my list of my features. But I want those to be holes, and Solid Edge goes out and sees that those are counterbore holes. But it gives me the flexibility to add a tolerance inside of here, so I have some more room for my bolts or my screws inside of there. The other thing we can do is add some treatment features, just like rounding, drafting, chamfers. All that is right at my fingertips with Solid Edge. Now, Don mentioned inside of here, as we go through a history-free system, we really don't have to worry about regeneration of the part in itself. If you noticed, as I drag and drop that hole above my protrusion in my list here, in a history-based system, you wouldn't be able to do that because you need the protrusion first before you have the hole. This is just to prove to you that regeneration of parts is going to be lightning fast inside of Solid Edge. So with that done, I'm before 5 o'clock. I get to go home, be with my family, and that's how we accelerate design inside of Solid Edge.
Yeah, excellent, Kyle. Thank you very much for sharing that, how we accelerate the design process with Solid Edge and synchronous technology. It was amazing to see how you could actually take that design, and you got that from your boss, and actually continue that brake assembly, and not understanding, having to deal with, did the engineer plan that in to make those changes? You were able to do that with no pre-planning and move that off the geometry around it. So exciting stuff. The next competitive advantage we'll talk about with Solid Edge is the ability to facilitate faster revisions. You might be asking yourself, faster revisions? What do you mean by faster revisions? Allow me to explain. In the fast-paced world of design and manufacturing, winning new business and making profits on projects can actually hang in the ability to respond to your customers quickly and efficiently. Solid Edge with synchronous technology has a unique capability that allows designers and engineers to make fast, flexible changes to models and drawings in a constraint-free environment, regardless of the authoring source. The way Solid Edge facilitates this is with an engineering concept I introduced on my previous slide, but I'll now go a little deeper. The way Solid Edge does this is by automatically interrogating the engineering model and presenting the user with possible design functions seamlessly at their fingertips. We call this live rules. It is like having an experienced co-pilot with you as you drive the software. And if that's not enough, the most valuable part of Solid Edge with synchronous technology is that models don't regenerate. What this means for the designer and engineer is that they can expect blazing fast performance. What does it mean to you and your customers? Well, Solid Edge with synchronous technology allows you to make design revisions in minutes instead of hours. This allows you to secure a competitive advantage in your business. I'd like to now pass it over to Kyle Ruda, where he's going to show you what we mean by faster revisions.
Thanks, Don. A couple of different ways we can actually look at revisions in itself. One is, think about this as any part that I open up inside of Solid Edge, I can actually make a revision to. And what we have inside of here is I have a part that came in from one of our sister companies. And it's a sister company that we just purchased, and they have SolidWorks. But it's my job to go in and make this revision to this part that we want to use on our motorcycle. And again, we've been told that we don't need counterbore holes anymore. We need to have simple holes, and we need to change them to 10 millimeters. So to make that change inside of Solid Edge is that quick. I don't have to worry about thinking about it. Now, Don was mentioning live rules. What live rules does is it actually, like Don said, interrogates that model. And as I'm moving this one face, notice everything else that moves along with it. That's that experienced co-pilot sitting right next to you, showing you exactly where you're going with your design changes. Now, one of the other critical things that we've been told inside of here is the distance between the holes needs to be a certain distance. So I want to be able to go in and I want to add a 3D dimension to this part. Now the critical dimension is 95 millimeters. So I can go through, and we have inside of Solid Edge what's called directional dimensioning. As I go through and move this, I really want this to grow symmetrically. So as I make this change inside of here, the part grows, and it does so by using live rules. You can see them. It's seen that it has concentric faces inside of it. It's showing that it's symmetric. All that is being seen by live rules. I can easily make that change. Now, Don also mentioned hybrid 2D, 3D modeling. What does that mean? Well, one aspect of it is a lot of times we really like to look at a 2D section view of this part. So what we do is perform that view inside of here just like you would inside of a draft file. And I'm able to go through and now put constraints, dimensions. I can lock this particular dimension down to be 9 millimeters to make sure that is always going to stay 9 millimeters. But we've also been told that is a critical dimension between these two faces is that it's 40 millimeters, or excuse me, 50 millimeters. And so as we go through here, I can select that information. So we can easily change this to 50 millimeters. But again, I don't have to think about how this part was designed. In fact, I didn't design it, somebody else did. So as you go through and think this, how would you have made that change inside of your CAD system? And how long would it have taken? Well, with Solid Edge, as you saw, it just took a few seconds to make that change. The other thing is I've been told that we need to remove this particular cutout. Well, I want Solid Edge to go through and select all that information for me so I don't have to spend time clicking all these little faces and rounds. It does it automatically for me. And so with that done, again, that's how we show how you can have faster revisions inside of Solid Edge.
Thank you, Kyle. Exciting stuff. The final competitive advantage I'll review with you today is the capability to facilitate better reuse. How many times have you been in a situation where you'd like to reuse an existing design and use that model as your starting point for a new design? Well, with traditional 3D modeling, reusing the data could cause the user many problems in regeneration and potential unplanned errors. In the end, it just might be easier to start over. Well, wouldn't it be nice to know that the day has come where you can reuse your existing data regardless of who authored it and regardless of what system it was in? The way we do that is with Solid Edge with synchronous technology. Solid Edge allows the users to make precise changes to imported geometry by adding 3D driving dimensions to any geometry. I know this is unbelievable and almost impossible to imagine, but we'll demonstrate this for you again in Kyle's demo segment in just a few minutes. Another unique capability within Solid Edge is the ability to make direct edits to imported geometry by pushing, pulling, and rotating this geometry with what we call steering wheel. You also have the ability to make precise edits and changes as well. This amazing capability will automatically recognize key features, allowing powerful parametric type modifications effortlessly. As I mentioned during the previous two advantages, Solid Edge with synchronous technology has a patented capability we call live rules. We're going to dive in a little bit deeper on live rules in just a few minutes as well. What does this all mean to your company, your design teams? Only you can answer that question. We believe this means a competitive advantage. And in many cases, this means lower overall design costs by having the ability to edit imported data and facilitate better reuse. Kyle, please show us what we mean by better reuse.
Thanks, Don. Many different ways we can actually think about reuse. We can either reuse existing designs that we've had either in a 3D form or actually in a 2D form. And that's what we do inside of Solid Edge. We utilize both ways of doing this. Now, one of the concepts that Don was talking about is a steering wheel concept. What do we mean by that? Well, steering wheel is just that. We're going to drive the geometry in the direction that we want it to go. And as you can see, we can input a precise dimension inside of here, given inside whatever angle or dimension that you want, but also have the freedom to move this particular geometry in a 2D axis to get it exactly where I want it. And once I do that, then I'm done putting it where I want it, and I can simply paste it inside of there. And as I do, notice that it automatically cuts that information out. That's how we can easily reuse the 3D design from another part. Doesn't matter where it came from, I can use it inside of here. Another way of looking at it is from a 2D standpoint. We can easily go out and use 2D drawings that we had either on our legacy or somebody sends me that 2D drawing. You have the flexibility to know that you're going to open up that 2D file and have all kinds of control over it. But one of the unique tools inside of Solid Edge is called Create 3D. Create 3D allows me to tell the system to go out, grab these views that I want. And yes, it will go out and fold them correctly, but however, it gives me the flexibility to tell the system where I would like those views to be folded into 3D space. So as we can see, we have my front view, we also have my right view, exactly where I want them to be. But I'd like to draw your attention to the dimensions themselves. We talked earlier about how whenever I lock down a dimension, it turns into a red color. But this case here, it is of an orange color. Why is that? Well, the system, again, is interacting with me, letting me know what type of dimension it is. And that is the visual feedback that you're going to get with Solid Edge in your designs. Now, as we go through here, I'm going to be using that 2D information to say how far do I want to extrude this particular one. Now, as we do this, I told you to focus in on those dimensions. You'll see the dimensions actually change colors. But they did more than just change a color. They literally moved from the 2D sketch over into the 3D. And if you blinked and you didn't see it, that's okay. You're going to get a chance to look at it again. Because as I go through here and I select the geometry that I want, I'm now going to extrude it out. And notice the 25 millimeter that's on top there. Another deal is the optionals that you have inside of Solid Edge to change your mind of how you want this geometry to actually be produced. Many different options right there at your fingertips. But if you notice that 25 millimeters, it's literally going to jump from the 2D right onto that 3D model. That's the power behind synchronous technology and Create 3D. Now I can come back and I can look at any other sketches that I've used, and I can reuse them at any point in time. In this case here, I want to be able to extrude out this middle portion, but I want to extrude it out to 10 millimeters. But again, I'm going to use the 2D geometry right there inside the view, and watch that 10 millimeters. It's literally going to jump off of the 2D right onto that 3D part. And then I can go through and say that is a critical dimension, and I want to lock it down. Now remember, these are the manufacturing dimensions from my drawing. So these are very critical dimensions inside of here. What I'd like to do is talk a little bit more about what Don was mentioning in his PowerPoint presentation, is this concept of steering wheel. Steering wheel allows me not only to move the geometry that I dragged and dropped in to reuse, but notice I can just pick one face and look what Live Rules is doing for me. It is going through and it is changing that information on the fly for me in the entire model itself. Now there's a couple of different ways you can do this as well to have more control over this precisely, and that's through the dimensions themselves. As I want to go through here, we can say that we have directional dimensions, and you can see as I change that option, it's highlighting that information on the screen. Change my value, Live Rules kicks in and says, look at all the geometry that I'm changing for you. And you have the option and control to go in and turn any of those Live Rules off at any point in time. But this shows you the power and how you can make those changes quickly, how you can reuse that information very quickly inside of here. And next, I want to be able to say, I want to do this as symmetrical. And so basically, I now have had 3 what-if scenarios of how I can go through and make a change to this part. So with Don, with that, that is how we reuse data inside of Solid Edge better.
Great, Kyle. Absolutely amazing stuff that you're sharing with us here. So the question becomes for many customers is how does this great technology translate into business benefit and a competitive advantage? For both NavC and Laserform, it meant exactly that, a competitive advantage in time savings. After adopting Solid Edge with synchronous technology, many of these companies are now reporting back to SIS and to Siemens drastic time savings, drastic cost savings. For example, NavC, which is located in southern Indiana, it's the Naval Surface Warfare Center. What they're seeing is just a dramatic time savings in their engineers' ability to accelerate their design process, have better reuse of their data, and accelerating the overall cycle time. Another company, Laserform, in the area of machine design and using sheet metal, is also seeing dramatic time savings in their ability to respond to their customers faster. Now just imagine for a minute what this type of advantage could have for your company, partnering with Solid Edge and SIS. Imagine the cost savings on each project. Imagine the reduced cycle time, the quality of life your engineers could have. Really, it comes down to getting the job done quicker and a competitive advantage for your business. So, simply put, how can Solid Edge with synchronous technology impact your business? It's a way for you to design better. Solid Edge with synchronous technology offers accelerated design for faster time to revenue, faster revisions for more repeat business, better reuse for more competitive pricing, and as I mentioned just a few minutes ago, it's about gaining a competitive advantage for your company. So at this point in time, we'll open it up for a few questions, Q&A. We did have a couple come in while we were sitting here doing the presentation today. Kyle, the first question we have come in says, Kyle, I noticed you brought in a SolidWorks and AutoCAD file, but what other file types can you open and save out?
Great question. And so what we can do inside of Solid Edge, from opening a file, you can be able to see all the different file types that we can open. From AutoCAD to SolidWorks to Inventor, MicroStation, Pro Engineer, SDRC, NX, the list is endless. And as you can see here, many different types of formats, even STEP, there's one add-on that we have called, and it's the CATIA add-on. That's the only one you have to pay for, but the rest of them come with Solid Edge. Now to save out, that really depends on if you're going to save out as a 3D file or as a 2D file. From a 3D standpoint, of course, Parasolid, JT, XGL, SIS, CATIA, again, if you have that add-on, iGestStep, STL, XML, Adobe 3D, and of course KeyShot if you have that rendering package. From a 2D standpoint, we have many different options. Again, opening, you can open up AutoCAD 2D, you can open up any MicroStation 2D, all those can be opened inside of Solid Edge. But to save out, which is what most people really want to know, is iGest 2D. Again, this as an Acrobat document, PDF, MicroStation, and of course DWG or DXF. And you have the full capabilities of your line types, your fonts, all that within inside of Solid Edge. So with Don, let's see if we have any more questions.
Yeah, thank you, Kyle. We do have one more question here online. The question is, I'm used to working in SolidWorks. How long will it take me to learn Solid Edge?
That is a very common question that we get, Don. And really, once you learn a 3D CAD system, you're that much closer to learning Solid Edge. But to make the transition a whole lot easier for users who are not used to Solid Edge, we have what's called the Command Finder, which is down at the bottom of my screen there. And whatever CAD system you're using, you can type in a command. So for a SolidWorks user, they have a command called shell. As I go through and look at that, we don't have a command called shell inside of Solid Edge. We call it thin wall. Now what it will actually do is it will show you what it is, and as you put your cursor on it, it will actually show you in the interface where that command is. And if you click on it, it takes you right into that command. So you don't have to worry about it. You can go right into it. And that is what makes your transition over to Solid Edge a lot quicker and actually will make you more productive. So back to you, Don.
Thank you, Kyle. At this time, I show no more questions on the web. On behalf of the entire team here at SIS, thank you for your time. If you're interested in next steps and what to do next, I highly suggest you reach out to SIS and their organization. They can actually talk to you on the phone about your design challenges. They can come meet with you and walk through your design process. We also have a public evaluation, a 45-day trial of Solid Edge on the SIS website. In the end of the day, it's about picking the right solution to help you gain a competitive advantage. And we believe Solid Edge with synchronous technology is a way that companies can gain a competitive advantage. So thank you for your time today and attending today's webcasts.